Today we're going to go over how we combine balancing equations, which we did at the beginning of the chapter, and mole conversions, which is what we just finished. So in order to do this, we will use the diagram that we have here. So if you're given the mass in grams, then you're going to use the formula mass or the molar mass to get to moles. If you're given the number of particles, then you use Avogadro's number to get to moles. Okay, once you have moles of what you're given, then you're going to use the ratio from your balanced equation to get the moles of what you're looking for. And then again, use the molar mass or the formula mass to get the mass, or use Avogadro's number to get the number of particles. So we're going to go through two examples of this in this video, and then we'll do a couple of examples in class as well. All right, so the first example we have is what mass of water is produced when 16 grams of methane, which is CH4, reacts with oxygen, which is O2, in the following reaction. So in the problems here, we're just going from grams of one thing to grams of another thing. Okay, so we're going to need the molar mass of both of them. So let's do that first. So the molar mass of methane we can get by doing 1 times the mass of carbon, which is 12.01, plus 4 times the mass of hydrogen, which is 1.008. And that gives us 16.04 grams, which is the mass of 1 mole of methane, or CH4. Similarly, for water, we can do 2 atoms of hydrogen, so that's 2 times 1.008, plus the mass of oxygen, which is 16.00. Okay, and that gives us a total of 18.02 grams per mole of water. Okay, now we're going to go from the grams of methane, which is given to us here in the problem, to moles of methane. So that's our first step. So if we have 16 grams of methane, we do that times the conversion factor where mole is on the top, because that's what we're trying to find, and on the bottom goes 16.04, which is our molar mass of methane that we just calculated. So 16 divided by 16.04 is 1 mole of CH4. Right now we can, this is the new part, now we can look at our balanced equation and say, okay, for every 1 mole of methane that we use up, we're actually going to make 2 moles of hydrogen. Okay, so this is the ratio of the coefficients in our balanced equation. So in this case, since we have 1 mole of methane, we know that we're going to make 2 moles of water, but regardless of how many moles of methane we had, we would just multiply by 2 to get the number of moles of water. Right, now that we know that we have 2 moles of water, now we're going to multiply that times the conversion factor where we have grams in the top, because grams is what we're trying to find. Right, so we're going to do 2 moles times 18.02 grams divided by 1 mole, and that's going to give us 36 grams of water. All right, so that's the mass of water that's produced when 16 grams of methane reacts. Now in this question we have how many grams of ozone, which is O3, can we produce from 64 grams of oxygen, which is O2, according to the reaction below. So the first thing we want to do, since we're going from grams to grams, we need to know the molar mass of each of these things. So the molar mass of O2 is going to just be 16, which is the mass of oxygen, times 2, which is 32. And the molar mass of O3 is just going to be 16 times 3, so that'll be 48 grams in a mole. Okay, now we want to take our 64 grams of O2 and convert that to moles. So 64 grams, we're going to do that times 1 mole over 32 grams, which is the molar mass of oxygen. And that will give us 2 moles of O2. Now, this one is a little bit more complicated in terms of the coefficients, but if we look, we have for every 3 moles of this, we make 2 moles of ozone. So we're going to do that times 2 moles of ozone over 3 moles of O2. And in this case, again, what we're going to is what goes in the top. So we're trying to get to ozone, so that's why the 2 is in the top. Right, so 2 times 2 divided by 3 gives us 1.333 moles of O3, or ozone. Right now, we know that the molar mass of ozone is 48, which we just calculated. So if we do 1.33 moles of O3 times 48 grams per mole, that gives us 64 grams of O3. Okay, and now we actually didn't have to go through all these steps for this problem, but I wanted to just for practice. But what you can see is we only have 1 reactant and 1 product, right? And because of the law of conservation of mass, or the law of mass conversion, anything that goes into our equation which would be 64 grams of oxygen, has to come out on the other side. And since 64 grams is all we put in and we only get one product, we know we have to get 64 grams of that product as well. So that is just additional confirmation that we did the problem correctly. All right, so we're going to do a lot more of these in class, and I'm going to give you a sheet with all the steps to make it a little bit more clear. And then this will be all that we're going to do before our next test next week.